graph, right? From here, most of you already said you think it's a rectangle, right? So that's what I'm gonna do. I'm gonna write the word rectangle here. But let me show you what it means to justify the reason. The characteristics of a rectangle must be proved. Just like we did on the first one, what are the characteristics of a rectangle?
Every rectangle is square, or something like
Every square is a rectangle.
Okay, so that's every square is a rectangle. All right, thank you. It's a quadrilateral.
and it's perpendicular.
Thank you, which is like the right angle thing. So you're right, but I'm gonna say for right angles, which is what you said, the perpendicular lines.
Wait.
And what else is a rectangle? Thank you, you got it. That's all of them. Let me ask you something. Are we trying to prove that the sides are congruent? No, we're not. Because with this, you can clearly see the sides are not congruent. So since the sides are not congruent, you don't have to do the distance formula to prove that. The only time you need to do distance is if you look at it and they seem to be the same and you need to prove it. So since all we need to prove is that it has four sides, right angles and a parallelogram, we're just going to have to find our slopes. Think about four sides. How can we prove four sides?
Oh, well, two of them are being right.
How can you prove it has four sides? Thank you. Look at it.
So there's no proof for that?
No.
I get it.
So like that's a geometry thing. I think they say that a lot of times. That's what I'm giving you. I'm giving you shit with four sides.
I would just put given for every single one of them. I don't remember like.
To prove that they're right angles, you have to prove that you have perpendicular lines. And to prove that you have perpendicular lines, you are looking for opposite reciprocal slopes. I'm going to abbreviate some of this here, and I'll move out the way so you can see. To prove that you have a parallelogram, we have to have parallel lines. And y'all, to have parallel lines, they have to be equal slopes. You see what I wrote? Make sure everybody see what I wrote. All I wrote is that we're trying to prove it is it has four right angles, prove perpendicular lines with opposite reciprocal slopes, and then prove it's a parallelogram by seeing if you have parallel lines, equal slopes. This means all you're doing is using the slope formula. You don't have to use the distance on this one. So I'm coming up here and I'm going to start you with the slope formula.
I think, is it
Each segment, baby. Hold on.
Equal.
It's what?
M equals x2 over x1? Or I mean x2 x1? Oh, it's the y or?
Yeah.
Yeah, you could just set it before.
Over X2. Okay, you don't do this. So I'm going to highlight because it helps me to visualize what I'm looking at. J or FJ and GH, you got to prove that those segments are the same. The slopes are the same.
I want
And the other
to.
two.
I don't want to get behind.
Okay.
Why are we finding the slope?
To make sure you're right.
Like what?
And to make sure that they're parallel sides.
So we're trying to prove that it has four right angles, and we got to do the slope formula to do that.
Yes, because to have four right angles, you have to have perpendicular lines.
Opposite slope.
Yes, opposite reciprocal slopes.
Yeah.
We're missing it. Perpendicular lines or opposite
I
reciprocal
want to get
slopes.
behind.
So we got, I highlighted F, J, and G, H. I'm going to look at F, J first. Segment FJ has a slope of, I'm going to feel really bad if I show y'all this.
What you got to do? You got to do it. Go ahead and do it. Are you saying break out rings?
I'm going to show you the formula, then I'm going to show you a shortcut.
It's a
Don't show a shortcut.
Nope, I'm not showing the shortcut first. Well, I'm gonna show you. I'm gonna show you FJ like I promised. So, 2 plus 1 over 2.
Wait, I thought it was minus.
No, I think that's it. I don't know.
It's a what?
I'm saying.
Other.
Yeah, so look at the formula here. The formula is y2 minus y1. Well, here's y2. And if I subtract this,
Ain't the shortcut right
Okay.
or wrong?
who said that? Oh, did I say that? Trevor had to say it. Tell the truth. Trevor said it.
Nah, I agree with Mr. Bridges.
That was Trevor.
Trevor told me to say it.
Oh my God, model math in here. Oh my gosh.
Tyler. Your turn.
I am so pleased right now because what I was gonna say.
Dude, for some reason, that plastic chair is killing me.
Bro, I feel like I'm sitting on hell, bro.
This is why I picked up this class.
He's can.
All of that I have to try to like.
We'll be like, oh wow, she's a flight teacher.
Oh my gosh. Y'all, let go. That was disgusting and distracting. I'm going to just write this here and leave it on y'all. I'm going to show you rise over run right quick. All you gotta do is start at your bottom point and then go up and go over. If you're going up, it's positive. If you're going to the right, it's positive. But if you're going down, it's negative. And if you're going to the left, it's negative. You're going to need to know that, especially when you do the other two sides for their slopes. So from G, I start and count up 1, 2, 3. And then I'm going to count over 1, 2, 3, 4, 5, 6. And then I simplify and I find that they have equal slopes.
It's kind of crazy.
Okay, so let me just say the reason why I showed you the formula is because with me, I've had some students who told me that they have a hard time counting the rise and run. They get confused, but they know how to do the formula, so that's why I gotta show you both. I don't mind if you show me the rise over run, but this is what I'm saying. Y'all don't get it twisted. You have to know when you're going left, it's negative. Because so many people on this one, FG, aren't getting it right because they're counting up, and then when they go to the left, they're not changing the sign. So like, let me show you. Segment FG. Let me change my colors. For FG, I'm starting here and counting up 1, 2, 3, 4. And that gives me a positive 4. But then I'm going to count over 2 to the left. Careless people just write 2. I'm just saying. So if you know that you're careless, you might want to stick with the formula.
I'm sticking with the formula. Because that looks like it's too easy to mess up.
I got -2 for this dimension, and y'all, try that one on your own and get that dimension.
All right.
Yeah, like fell out with the
But that's what I'm talking about. I'm literally sitting here trying to
Yeah, that's true.
But I'm trying.
Yeah, this is a problem.
No, we don't get paid.
Exactly.
Exactly.
Another one's negative.
Okay. Let's connect this. Look at the bottom. You said that it was a parallelogram, so that means that they have to have equal slopes for your parallel sides. They do. You said it at right angles, which means you have to have opposite reciprocal slopes. Do you have that?
Yes.
Yes. You have just proven,
Wait, what does that
This
look
here.
like? What is opposite reciprocal
it
slope?
looks like.
Miss Presser, Miss Presser, Miss Presser.
I don't know what that is either. I asked Chandler and she said, I don't know what that is.
Like, when you look at that square, Miss Presser, what made you say that's the opposite slope reciprocal?
Opposite reciprocal of this would be -5/2.
Oh, so 2/1 is -2?
Well, technically, I'm not gonna write 2/1, but if it were 2/1 and you flip it, it would be -1/2. Whenever you have a whole number, like -6, for example,
But it's a
that has a
slope.
1 underneath it.
Well, yeah, always.
So then that means the opposite reciprocal slope is gonna be +1/6.
So you gotta get rid of the get rid of the sign.
Correct. So like if it's a positive, make it a negative, that means that's the opposite part of it. And then whatever it is, you flip it, that's the reciprocal part.
Okay.
Y'all are actually being amazing right now. I'm gonna take it. You gonna do number 3 on your own though, since I know I wasn't gonna do all that, I helped you on every bit of it.
Please support your work.